Hi friends, I welcome you all to the course of Marketing Research and Analysis, the second part. In the last lecture, we were discussing about analysis of variance, one factor, and then we went ahead and discussed about n-way ANOVA, where more than one factor is present. That means, one factor is basically you can understand as one treatment, right. So, the levels of one treatment, or that means one independent variable which is categorical in nature, and that independent variable or that treatment may have 2 or 3 levels, whatever 2 levels or more than that. So, in that condition we use a technique called the analysis of variance, and when we have more than one factor, that means 2 types of treatments given to see the effect on the dependent variable, which is a metric variable, continuous or measured in a ratio or interval scale. In that condition we use a 2-way ANOVA or 3-way ANOVA or 4-way ANOVA, that is why it is called a n-way ANOVA, right. As it goes on increasing the number of factors, independent variables, category in nature, as it increases we say it is a n-way ANOVA. Then we discussed about the case of multivariate analysis of variance, where we said what if there are more than one dependent variable, both measured in a continuous or metric manner. So, in that condition we said there are 2 possibilities, that there is only one independent variable or one treatment with several levels, or it could be again 2 independent variables with 2 or 3 levels, right. So, when we have one independent variable with 2 dependent variable, we said it is a one-way ANOVA. But when we have more than one independent variable, all categorical, measured in categorical manner, then we said it is a 2-way or more than that n-way ANOVA, right. So, 2-way ANOVA, 3-way ANOVA exactly. But what if in a condition now we want to control another important variable, which is a confounding variable, and its presence is affecting the dependent variable, the results, the effects on the dependent variable. So, in such a condition, when you have a case of a dependent variable and then an independent variable which is again categorical normally, and but you have another variable which is a continuously measured in a which is measured in a continuous scale, and this variable is now also part of the independent group, and this affects the dependent variable. So, when this happens, so this is a case where we use a technique called analysis of covariance, right. So, what I will explain what is each what does it mean basically. So, let us start. ANCOVA, as I said, ANCOVA is just nothing but an extension of the ANOVA, only the letter, if you can see, the letter C is attached here, which stands for a covariate. Okay. So, what is this covariate? I will explain that. It is an extension of an ANOVA in which the main effects and the interactions. Now, I think by this time you must all be clear from my lectures what main effects means and what is an interaction effect, right. So, this main effect and interaction effects are assessed on the dependent variable scores after it has been adjusted for by the dependent variables relationship with one or more covariates, right. So, let us now talk about only one covariate. So, what is this covariate? A covariate is a part of the independent variable group, but this is not measured in a categorical manner, categorical scale, but it is measured in a continuous scale, right. That means, it is measured in some interval or ratio scale. So, this presence of this covariate is makes an impact on the dependent variable. This analysis proceeds by combining a regression model with an analysis of variance model. That means what? If you remember in the ANOVA, what we said was the y, my dependent variable is a continuous, is measured in a continuous manner or metric scale, and my independent variable is categorical, that is what we have said is categorical. But now, since there is a presence of a covariate, right, another independent variable which is a covariate, right. Why it is called a covariate? Because it is measured in again a metric, a continuous manner. So, this is categorical, this is continuous, right. So, when I am having 2 such independent variables and I am measuring its effect on the dependent variable. So, we can see that this, if we take only this much, only take this much, it is like an ANOVA, it is a case of ANOVA, right. But what if I take this one, right, along with this, right. If I take this y and only the covariate, which is again a continuous variable, then it is like a regression model, right, both are continuous. So, both are metric. So, that is what satisfies the case for a regression model, right. So, what is this what is saying? The analysis proceeds by combining a regression model with an analysis of variance model. Okay. For example, imagine that we found that boys and girls differ on the maths achievement or the score of maths, how they perform in their maths. However, this could be due to the fact that boys take more maths courses in high school. That means, boys take more maths courses due to pressure from family, or maybe they are interested, whatever we have seen by generally that boys are more interested into mathematics, numbers, and girls into the more creative side like arts, drama and all. So, maybe boys take more maths courses in comparison to girls. So, ANCOVA allows us to adjust the maths achievement, the scores, based on the relationship between the number of math courses taken and math achievement. So, if we do not take this, for example, let us say what would have happened had we taken the effect of gender on the math score, whatever we would have found might not have been justified or correct if we do not take this point ki how many number of courses that has a boy taken in comparison to the number of courses taken by a girl in the area of maths. So, the more somebody has taken the courses, automatically we will infer that his understanding in the subject is higher than to the other the boy or the girl, right. So, that is why the presence of this variable, right, the number of maths courses taken helps us to control and understand the effect actually, the right effect. Okay. So, we can then determine if boys and girls still have different math achievement scores after making the adjustment for the maths courses that he has been taken, right. So, now we understand what is actually this ANCOVA. ANCOVA means we are finding an effect on the dependent variable with the help of the independent variable, which is categorical, but we have a control variable which is the covariate, basically is measured in a continuous scale, and by adjusting for this covariate we see what is the change in the dependent variable. That is simple, that is exactly, this is what we are saying, right. So, how do you define a covariate? It is a variable that is related to the dependent variable, right, it is related. So, the math score achievement and the number of maths courses he has taken are related, which you cannot manipulate. You cannot manipulate, that is the data given to you, but you want to account for its relationship with the dependent variable. But although you cannot manipulate, but you want to know ki whether this boy has taken how many courses and this girl has taken how many courses, because the number of courses they have taken, that will have an effect or a bearing on the dependent variable. So, this relationship is important for us. An effective covariate is one that is highly correlated, right, with the dependent variable, but is not correlated with the independent variable. That means, in this case the gender and the maths courses taken, right, logically they should not be related, but the score achieved in maths and the maths number of courses taken should have a strong correlationship, right. For example, let us take another example. You are running an experiment to see how corn plants, right, corn plants tolerate drought. So, we will take some dependent variable to measure that how the corn plants are tolerating drought, a drought condition. Level of drought is the actual treatment. So, level of drought, suppose it is 1 not so much, 2 higher average, 3 severe drought, right. But it is not the only factor that affects how plants perform. So, we say the scientists are thinking ki the level of drought is not the only condition that will affect how the corn plants will tolerate the drought. So, then what is the other factors that affect? Let us see. So, he says the size of the plant is a known factor that affects the tolerance level. So, if a plant is only let us say few days old and if a plant is let us say a month old, so then the size in the plant, the difference in the size in the plant in the same maybe category will have an effect, different effect on the dependent variable, that is how the plant tolerates the drought, right. So, here you see how the plant is tolerating the drought and the size of the plant is will have high correlation, the dependent variable and the covariate will have high, but the level of drought and the size of plant, that has got actually no correlation, right. So, now let us see another, now this is an example, another example. A school is exploring 4 methods of teaching, 4 methods of teaching. So, what is this 4 method? Let us say A, B, C and D to their children, and would like, so A, B, C, D are 4 methods. So, these are, what is this? This is a categorical variable, right. So, this is my first which is my independent variable, okay, to their children, and would like to determine which method is the best. It selects a random sample of 40 children, 40, and randomly divides them into 4 groups. So, we have studied in factorial design that randomness is one of the most important criteria in any experimental design, right, using a different teaching method for each group. So, 10, 10, 10, 10, 4 groups. The reading score of each of the children after 1 month of training was recorded. So, first A, B, C, D is the 4 training methods, teaching methods of training, and randomly 40 people were divided into those 4 groups. 1 month was given spent on training, and then the reading score was measured. Before doing the analysis, one of the researchers said or thought that the scores of the children would be influenced by the income of their family. Why? How income of their families will affect? Let us see. Speculating that children from higher income families would do better on the reading tests, no matter which teaching method was used. Why? Because maybe since the children from the higher income families have an access to more number of books and better educational facilities, so their reading abilities, and their parents might be more educated than the rest. So, their reading habits would be better in comparison to the ones who are coming from a poor income family, right. So, so this factor should be taken into account when trying to determine which teaching method to use. So, this now you see, this is my what this income is my covariate, okay, income is my covariate. So, you have a covariate, you have a independent variable, and what is my dependent variable? The dependent variable is my score, reading score is my dependent variable, right, okay. ANCOVA versus ANOVA, what is the difference? So, only the difference is we are saying C, but let us see. Makes ANCOVA potentially a very powerful test. It is easier to find significant results than with ANOVA alone, right, by potentially reducing the MS error. Now, what is this MS error? I have already taught you, explained to you analysis of variance, in which I have said to you 2 things: mean sum of square between the groups, mean sum of square within the groups, or it is also called as error, mean sum of square error, right. So, it says ANCOVA, if you take a proper covariate or you select your covariate properly, it helps you to potentially reduce the mean sum of square or within error to a significant manner. Generally, the more strongly related are the covariates and the dependent variable. Generally, the covariate and the dependent variable are strongly correlated, that is what I had explained earlier also, and unrelated the covariate and the independent variable. So, the covariate and the independent variable are unrelated, not correlated, right, and the covariate and the dependent variable are but strongly correlated. So, the more useful the covariate will be in reducing the MS error. So, that means what? In simple terms, to understand, if you select your covariate in the right way, then your statistical, the mean sum of square within, or the internal within the group, the sum of square, that error will reduce, and if that error reduces, you only say what will happen. You think F ratio is nothing but, we said, M sum of square between by M sum of square within, the mean sum of square within. So, if this is reducing, automatically my F value will go up, right, okay. So, what is the relationship ANOVA and statistical power of a test? With the help of a good covariate, ANCOVA increases the statistical power of the test, just I was explaining. The covariate's role is to reduce the probability of a type 2 error. Now, do you remember type 2 error? Type 2 and type 1 error. Type 1 error is alpha and type 2 error is, type 1 is my alpha and type 2 error is called beta. You remember that? Alpha is my type 1 error. Type 1 error means when the chances of rejecting a true null hypothesis, chances of rejecting a true null hypothesis, and what is my beta? Type 2, the chances of accepting a false null hypothesis, right. So, that means a covariate reduces a right covariate reduces the probability of a type 2 error, that means it reduces the chances of accepting a false null hypothesis, right. So, that means what? If you do this, or this is called the power of a test. So, 1 minus beta is called the power of a test. So, if my beta is reducing, so what is happening? My power of the test is increasing. So, the statistical power of a test increases, right. So, what it says is when tests are made of main is reduce the probability of type 2 error when tests are made of main or interaction effects, or when comparisons are made with planned or post hoc investigations. So, understand that beta reduces with a right covariate. Since the probability of a type 2 error is inversely related to the statistical power, the ANCOVA will be more powerful than its ANOVA counterpart, presuming that other things are held constant. So, keeping all other things constant, the probability of the type 2 error is reducing, that means beta is reducing and the statistical power of a test is increasing. As you have seen, the F test associated with a standard ANOVA are computed by dividing the MS for error, that is we said MS within, right, error, right, or within, into the MS for the main effect. So, when a good covariate is used within a covariance analysis, it reduces the mean sum of square error and thus increases the F ratio. This is exactly what happens. So, just if you just understand this much, when I am using a ANCOVA, the ANCOVA is more powerful than ANOVA because it reduces helps me in reducing my within error, and thus it increases my F ratio and my chance of significance or rejecting the null hypothesis increases. Okay. What are the basic requirements? I need one dependent variable which is measured in an interval or ratio, a continuous scale. I need one independent variable which is nominal or ordinal, so discrete or I say categorical. Okay. So, if you do not have let us say a independent variable which is let us say categorical nature and you have a continuous scale also, you can convert that into a categorical scale. For example, let us say income, you have the exact incomes of people. So, let us say 1 lakh, 2 lakh, 3 lakh, 4 lakh, 5 lakh, 6 lakhs. So, what I will do is I will say this is one group 1, right, this is let us say another group, right. So, now I have converted this same dependent continuous variable into a categorical variable, right. So, that can also be done, and one covariate I have which is in a again in a continuous, right. Okay. So, this is the just understanding what is dependent variable, this is okay. What is the basic requirement? The minimum number of covariates that are uncorrelated with each other, right. You should have minimum number of covariates which and that should be uncorrelated. Why? Because you want a lot of adjustment, with the dependent variable with minimum loss of degrees of freedom. So, the change in sum of square needs to be greater, the change in the sum of square needs to be greater than a change associated with a single degree of freedom lost for the covariate, right. As it is uncorrelated with the independent variable, the covariate is uncorrelated with the independent variable, that means it says it should be the example, the covariate should be collected before the treatment is given. If you give a if you collect the score, right, the covariate, what is the covariate? Now, I know in that maths how many times the exams has been taken by the boys and how many times the exams have been taken by the girls. So, if I have collected this data beforehand, right. So, then what it does, it helps me it helps to avoid diminishing the relationship between the independent variable and the dependent variable, right. So, that is it says CV should also be uncorrelated with the independent variables in order to avoid diminishing the relationship between the IV and the DV. Okay. Generally, more strongly related are covariate and dependent variable. Covariate and the dependent variable, higher correlation is very high, and unrelated in the covariate and the independent variable, the more useful the covariate will be in reducing MS. So, it is more or less repeating the same thing which I have been telling in the last slide. So, as you increase, as you select a proper covariate, the mean sum of square within or the within error reduces. Okay. Now coming to some of the assumptions. First of all, when you do an ANCOVA or ANOVA for that, or all of these techniques, right, they fall under the except the ANOVA, the others fall under GLM, right, general linear model methods, right, because they encompass a large number of statistical models into one linear equation. So what it is saying is, the assumption is, first of all there should be no missing data. If there is any missing data, you should correct for it, right. So I have explained that earlier in my earlier lectures how to correct for missing data, right. So you can replace, you can make replacements. Then it says your dependent variable and covariate variable should be measured on a continuous scale, fine, no issues, okay. Your independent variable should consist of 2 or more categorical independent groups, this is also fine, so right. So there is nothing in this. Now coming to this point, independence of observations. This was also applicable in ANOVA if you remember, which means that there is no relationship between the observations in each group or between the group themselves, there is no relationship, right. So for example, what it says, there must be different participants in each group with no participant being in more than one group. So this participant is not being repeated, right. If you want to repeat, then there is another kind of method which is called the repeated measures ANOVA or repeated measures ANCOVA, there is another method, right. This is more of a study design issue than something you can test for, but it is an important assumption of one way ANCOVA. If your study fails this assumption, you will need to use another, that is what I was saying, another statistical test instead of a one way ANCOVA called a repeated measures design, right. Repeated measures, as the word suggests, you are repeating the respondent, the sample, right. Second, there should be no significant outliers, a slight difference is okay, but a significant outlier or a large outlier in large or too small whatever, right, can affect, because you remember that these techniques are basically a test of means and proportions, right. So they get affected if there is a presence of an outlier, okay. So it says an example, outliers are simply data points within your data that do not follow the usual pattern, right. In a study of 100 students IQ scores, the mean score was 108 with only a small variation between the students. One student had a score of 156, which is very unusual and may even put her in the top 1% of IQ scores globally. Now this is an outlier. So if this outlier is justified, if really somebody has got it, it is he or she is a genius, so no issues, but generally such outliers will distort the whole whole statistics. Then normality. So we should ensure that our variables, the normality of the sampling distribution of the dependent variable and each covariate, the dependent variable and the covariate should be following a normal distribution, okay. And you know how to check for normal distribution, you can do it through a plot, right, through a normal histogram also, or a PP plot, or you can go to you can measure it through by measuring the calculating the in SPSS you can go to explore and find out the Mardia's coefficient, right. So you can calculate the Mardia's coefficient. If I have already shown, you can go back to my lectures earlier and you can check that. So and I said it should range between -2 to +2, so you can check back that. There should be an absence of multicollinearity. If you have, let us say, more than 2 covariates, these 2 covariates or 3 covariates or whatever, then there should be an absence of multicollinearity. If there is a multicollinearity, a serious strong correlation, heavy correlation between the covariates, then it is again a problem, right. There needs to be homogeneity of variance. Now by now I think you must have heard how n number of times what homogeneity of variance means. Homogeneity of variance means that there has to be, all the groups need to have a equal variance among within themselves. That means the variance in the group should be equal. That means if there are 5 groups, all the groups should have equal variance. That is what it says, homogeneity of variance. If that is there, then only we should go ahead and compare the groups, right. Another important thing is covariate linearly or is known or in known relationship to the dependent. Here there is something called the covariate should have some correlation, some correlation with the dependent variable at each level of the independent variable. So it says there has to be some correlation at least between the dependent and the covariate. Independence of the error term is independent of the covariates and the categorical independence. Randomization in experimental design assures this assumption will be made. So, the error term is independent of the covariates and the categorical independent variables. Okay. Next is there needs to be an homogeneity of regression, right. Now, what is homogeneity of regression? The relationship between each covariate and the dependent variable should be the same for each level of the IV. Now, look at this. So, this is my dependent variable, this is my covariate, there are 3 levels, right. So, if you see these 3 lines, you can understand they are not meeting each other, they are not interacting at any point. So, there is a homogeneity of regression, but look at this same condition group 3, group 2 and group 1. So, now this is not showing a homogeneity, rather this is a case of a heterogeneity of regression, right. So, you should always be trying to see that the homogeneity of regression assumption is met. How to do that? I will explain, right. This is how you check the assumptions for ANCOVA. So, the 3 assumptions: covariates should not be highly correlated, covariates should not be highly correlated, right. So, how to do that? Check the correlation before performing the analysis, check the correlation among the covariates, use analyze, go to in SPSS analyze, then correlate, bivariate correlation and check that none of the covariates have a correlation more than 0.81. What to do if the assumption is not met? If there are some highly uncorrelated covariates, right, correlated covariates, one must select which covariates are of most importance and use only those in the model. Suppose you have 2, 3 covariates and there is a strong correlation between, let us say 1 and 3, then you may decide only which one to keep and which one to avoid, right, because if there is strong correlation they actually mean the same thing, they are meaning close to the same thing, right. Residuals should be normally distributed, right, or the errors should be normally distributed. What does it mean? How to check? First, use the save menu within GLM, right, to request the standardized residuals for each subject. So, when you go to the GLM model, there is a option for measuring for converting into standardized, right. So, to the for each subject to be added to the data set. So, when you do a standardized, you standardize the scores. So, the standardized values will be added to your data set, right. So, you simply, if you want to do it like this, go to analyze, then go to descriptive statistics, go to explore, and in explore you go for there is a provision for standardized scores, right. In I think descriptive also it is there, right. I will show you. So, explore and explore to produce histograms and there is you can check whether the data is normal or not. If the residuals are very skewed, the results of the ANOVA are less reliable. One possible method of solving this is transformation of the data. Now, that also we have covered in earlier classes. So, transformation you can convert into a inverse transformation, a log transformation, a square transformation, a cubical transformation, any of these, right. Last, homogeneity of variance. The variance should be similar for all the groups. So, Levin's test is the test which is carried out to check the homogeneity of variance. Now, if your homogeneity of variance is violated, then the results of the ANOVA are less reliable. So, in such a condition, the best thing is to transform the data. I hope this is all for the day. So, we will stop here, and in the coming class we will further move ahead with ANCOVA, and then we will also try to cover MANCOVA, and I will also help you to explain how to do that with an example in the SPSS, right. So, that will not only give you a theoretical clarity, but it will also help you to understand and utilize the techniques in your own research work, right. So, for today, thank you so much, all the best.